co-developed the Panga GPS cockpit application. My name is Megan Kostick and I am our team lead.
I'm Wendy Stockwell and I'm the requirements analyst.
I'm Sergio Abutis and I'm the database specialist.
I'm Kyle Kincaid and I'm the software architect.
I'm Rosie Stahl, quality assurance lead.
Our client for this project is Tim Melbourne and his associates. Tim is an associate professor here at Central Washington University and also the director of Panga. Our advisor is Dr. Rosvan Andonier, and he is a teacher here in the CS department. Just to tell you a little bit about what we're going to discuss this evening, we're first going to give you an overview of the project, just to refresh, go into the specific requirements and risks, and then we'll recap about everything we did this quarter and talk a little more in detail about the database, the graph view, demonstrate our application, and finish up with quality assurance and testing, conclude and answer any questions you guys may have. So to give you a little bit of background on our project, the USGS is the United States Geological Survey. They're an organization that funds various research groups that research different things about the Earth in hopes for a better well-being of life on Earth. Panga is the research group here at Central Washington University. Panga stands for the Pacific Northwest Geodetic Array, and our client is the director of this group. They are funded by the USGS along with NASA to research various aspects of geology. So the Cascade Subduction Zone stretches from Canada down through California, and so we live along the subduction zone. And the subduction zone has two plates, one subducting under the other. And anytime this may fault, it could result in an earthquake, which could lead to a tsunami and other natural disasters. And so what they've done is placed various GPS sensors throughout this region. And these GPS sensors are collecting data in the position of the Earth. This allows them to view the movement in the north to south direction, east to west direction, along with the vertical up and down motion. Now right now, most of these sensors are used to increase GPS precision on the different devices, but they think that they're going to be able to reformat this data and use it to track the motion of the plates and increase emergency response time, and also be better able to pinpoint where the fault occurred. And so this takes me to the problem that we're solving. So our client asked us to create an application so they could visualize this data they're collecting. Right now it's coming into the server in the geology lab downstairs here, and it's coming in and going out. They're not able to use it or view it. So they want a way to view it to create these better emergency response systems. And they need it to be a real-time display, because this is time-sensitive data that it definitely matters if you are able to notify people in 2 minutes versus 20 minutes to give them more time to reach safety. And so our solution was to develop an extendable application that would view this data they're collecting. And I'll now pass it on to Wendy, who will talk more about the requirements.
Thank you, Megan. So our project has two set lists of requirements, the first being the functional requirements. Our client has asked that we create a GUI that has a station list so that the user can select a station. And they've also asked that we create a map view that will plot that selected station, a graph view that also plots the data from that incoming station, and a saving function that allows the user to save the graphically represented data into an image format. They've also asked us to create tabs so they can view the graph view in a larger tab and multiple other tabs that are going to be used in future extensions. The final thing is the site description that allows the user to see pictures around the site and an actual description. On to our non-functional requirements. The user has asked that we create an independent Java desktop application that is also cross-platform compatible so that users with Mac OS can use it, Linux, and Windows can also use it. They've asked that this be a real-time data streaming application that can connect to their database as well. After gathering all these requirements, we must assess the key risks that were involved in this project, the first being faulty code. second being a loss of information and the loss of a team member, and finally a dissatisfied client. The way we have combated these problems was to first make sure that every group member was able to perform on any bit of code, and in case that we have a loss of information, we have multiple backups, and we have allotted that 2 team members be working on the code at any given time. On to the quarter recap. We have 3 iterations completed this quarter. We've had major changes to our GUI, such as the station description being added in, and we've modified our graph view to include the station or the snapshot feature, and an ability to configure the axes of the graph. Our client has updated their aggregator so that we can now stream real-time data into our graphs, and we have also almost completed our testing of our project. I will now pass our presentation on to Sergio, who will talk about our database.
As mentioned earlier, the main purpose of our application is to provide the user a visual representation of the data that is being collected in real time. In order to do this, the data must flow through a series of steps before we're actually passing it on to our graphs. At the start of our project, our client already had a system in place that would connect to the stations that are out in the field and store the data that is being collected from those stations in their large database. They also had an aggregator system in place which allows them to query or to get data from that server and pass it to whoever is needing it through the aggregator. So our program is then supposed to connect to this aggregator and store up to 24 hours of the data in our local database. From our database, the data is then passed along onto the graphs, and that is how we form our real-time graphs. So the aggregator, as I mentioned, is an interface that connects to the client server. And during the last development iteration of our project, the client updated this aggregator, which it now gives us the station's change in position rather than the actual position of the station. And this change in position is what we actually want to plot on the graphs. We create the aggregator about once every second for new data, and any new data that is returned from the aggregator is inserted into our database. In parallel to this process, we have a graph data collector, which is monitoring our local database and retrieving any new data that is inserted and plotting it on the graph. To provide consistency with the graphs, we use the client server time rather than the local machine time. And so we store all this information in our local SQLite database. And while SQLite provided us with all the functionality we needed for our application, the fact that it is based entirely on a single file did cause some problems while we were developing our program. One of the main problems we had was that since it is based on a single file, and we were constantly trying to access the database with read and write operations, it was causing a lot of file locking issues and it was slowing our program down. To solve this problem, we decided to make an inline aggregator, or a class within our Java application, which handles all of the database functionality. In this class, there are methods that handle each of the queries that we need to access, or to insert data into the database and read from the database. Doing this, along with controlling how often the database changes are actually committed to the file, allowed the database to perform much more efficiently and solve all the problems we were having with the database locking up. So that sums up the database part, and I'll now let Kyle speak more about the actual graphing of the data itself.
Alright, so for this project, we obviously needed a real-time graphing library, and it had to be open source. That's actually why we chose JChart2D, but another reason why we chose JChart2D is because it is really well documented, and we've never worked really with this kind of third-party library before, so that was really helpful. And we had a few issues with this third-party library because it didn't fully meet the client's needs. It didn't appear as though they needed it to. It didn't display the data how they wanted. And so we had to make a lot of changes. First of all, we had to make a lot of changes to the way the axes worked, such as their titles, the placement, and the layout, and just general things with the titles. Also, you can see that the labels have timestamps kind of, or how old the data is at that x-axis. it goes into the negative. And this allowed it to be more intuitive to the user to see, like, I guess, what they were actually viewing and how all the data they were viewing is. So that was really important. Another issue that we had with this library was that the x-axis actually scaled, and with real-time graphing, it kind of breaks it and defeats the purpose completely, especially when comparing a lot of graphs like our system does, or the user will do with our system. So we had to completely remove that scaling functionality. And we had to find a few workarounds for that, but we ended up making it work and work efficiently. Also, to make it more intuitive to the user as to what they were modifying and how they were working with the individual graphs, we had to add buttons. So to do this, we actually extended or recreated the chart based on the open source material, and then added in the buttons ourselves and gave those functionalities, such as the snapshot feature and the configuration and removal of these graphs. So now we're going to show you a demonstration of our application. And so once we start it up, you're going to see the splash screen, and this was requested by the client to really say who contributed on the project and show them that we developed it and who funded the program. So you can still select and search for streams in the station list on the left. And when you actually select a specific stream, you'll see that it changes the station description now. And this information is actually gotten off of the web server of Panga, and each station has its own individual website, although some of them don't. So when that happens, it'll tell the user there's no description available. And also, when you select a station from this list, you can see that it highlights the specific station on the map and also centers on that. This just tells the user that that's what they're looking at. And yeah, so once you actually select a station from the map, it'll still come up with the stream selection, and they can still make the graph by selecting a specific stream. And we still catch errors with these windows, like if they don't fully select, or they don't select any stream, for instance, it'll still tell the user you have to select one. Thanks to Sergio's aggregated or inline aggregator that he collected, you can actually just add a ton of them. It's really up to the processor of the system to determine how much you can add. We don't specifically stop it, but it will hold a lot and work really well now. You can see that this is actually live data. You can see that we have gaps in the data. That's when the application wasn't running, for instance, and the database hadn't been collecting data. So that was a request from the client. Also, when you increase the window of time, you will see that there's a huge gap to the left, and this is because we've removed the scaling. And that's really important when, for instance, you're comparing multiple graphs with the same time window. You don't want one to be like, oh, you have the last 5 minutes of data, but you really want to see the last 24 hours. It's going to stretch across. That's not going to happen anymore. And also, we have a snapshot feature, as I mentioned earlier, that will allow the user to save what they are viewing on that graph at that specific time in a number of different formats. So if she saves that to the desktop, we should be able to open it up. And there it is. All right. So we also have tabs. We still have tabs for extension, and we've been given images from the client to kind of show what's going to happen in those areas, the different transformations with the map, and that's for future groups to work on or whatever they want. And that concludes our demonstration. Now Rosie will talk about quality assurance and testing.
All right. With this being our final iteration, we redoubled our focus on testing, and specifically we wanted to focus on the formal acceptance testing. We've been doing acceptance testing every week, and that's sort of been almost a weekly demonstration as of this iteration. But with the formal acceptance testing, we began, after we started streaming the real data, we asked our client and his team to fill out the user response forms, and When they filled those out, they discovered the title and label issues that Kyle mentioned earlier. They also discovered the major scaling issue, and once we fixed those, they seemed a lot happier. So when we did our weekly demonstration this final time, we were able to observe how our client interacts with the application versus how we interact, so that we can see where their priorities are and kind of match our priorities to what's most important to them. And now we have completed the project, and they're very happy. Since this is our wrap-up phase and our system polish, I'll share some of our final stats with you. We have roughly 3,700 lines of code, and that's not including the generated code from using NetBeans to create the GUI components. We've declared our project completed at revision 97, and that's using Subversion through NetBeans, which has worked very well for us. We've encountered only a few collisions, and those collisions did not result in any major loss of data, thankfully. So, let's see. Our code coverage goal has not yet been reached, but that's according to JUnit. And JUnit kind of considers into that percentage the GUI components, which are a little bit hard to test, but I'll get to that. The picture on the top right shows some of our simpler tests, because we approached unit testing with the idea that no method and no class is sacred, so even the little setters and getters are being tested and they have to pass. And on the bottom right is probably the most difficult unit test we completed. That's the trace painter dot. It took us a day and a half to just intense focus and a lot of effort, and now that it's passing, it's definitely a point of pride that it is 100% functional. Oh, we also are reaching our goal with the comments. As stated in our previous presentation, we wanted to include the multi-line comments that could generate Java docs, and we are making really good progress on that. We're almost completely commented throughout the code with the multi-line comments stating what the parameters are taken by the method, what data structures are used in the method to make it work, what it returns, and kind of our intentions. And as you can see in the generated Java doc, you can see basically how we want this to be passed on for the future contributors and how they can use what we did to make their lives a lot easier. Getting back to our unit tests, with the GUI components, we sort of split our testing for that in half. We took the back-end functionality and kind of called it a scavenger hunt. We took behind the scenes of the GUI, we said, if this functions on its own, it's a 50% pass. And then when we do the system testing, if it works inside the GUI, it's a 100% pass for that particular component. And that's more of a 90% completion on our unit tests there versus JUnit stating that we're not anywhere near that. So JUnit is a liar, we're right. Getting to our biggest issue, when we did our system testing, we need this application to run for not just an hour. We need it to be able to run for potentially days or even weeks. So when we did our system testing, we discovered a fantastically horrible error called a memory leak. After about 20 minutes of running with just 3 stations, it was reaching about 300 megabytes of consumed memory, and it would crash at exactly 34 minutes no matter how many stations, no matter what we tried. We spent a week trying to figure out where this was coming from. And after a lot of hair pulling, we discovered that there were 2 connections that were not closing correctly. So once we fixed that, we were able to run 6 stations? We were able to run 6 stations for 12 hours, reaching only a total of 70 megabytes of memory at 20 minutes. And it leveled off there. So at 20 minutes, we cut our memory consumption to about a 1/4. And at 40 minutes, we were at about a 10th of what we were before we fixed that issue. So that's our testing crowning achievement. We defeated the memory leak. And our overall testing completeness is about 90%. And I'll pass it back to Megan to conclude the presentation.
All right, so as you've seen, we finished our final iteration with our system polish and making sure our clients, everything was satisfied for them. Just to kind of point out the major issues with this project and the things that we've learned. So dealing with an aggregator, none of us had even heard of that before. And coming into it with being told no one has done something like this before, no one's tried to get this data out. Overcoming that and finding a way to get that data was a huge accomplishment and learning experience, and probably one of the biggest hardships of this project. And also, we were dealing with SQLite, which obviously is supposed to be easy to implement. It's embedded everything, and that wasn't a problem. But the fact we couldn't do simultaneous reads and writes was going to be an issue with real-time data streaming. So we had to find a way to fix this. And going through, having multiple connections, that locked up, crashed the program, I lost my train of thought. Okay. And also, when it would look really choppy if you would be reading and writing like automatically, that chart just wouldn't move correctly. And so we needed a way to fix that. And as Sergio stated, he created his own version of an inline aggregator, which allowed us to set the amount of times they could commit or the time period. And that seemed to free up our issue and allow the data to flow in a more real-time view. Also, the memory leak, as Rosie went on all about, that really set us back about a week. We didn't know what was wrong, and if our application can't run for days, there's no point in having it. So we had to fix that, and once that was fixed, we were able to get back on track and solve our final issue of the x-axis scaling. So JChart2D was everything well documented. We could implement it easily, but our client didn't want that scaling. It made things almost unreadable on the map. And so finding a way to work around that was our burden the whole time. And so we were really excited when we got that working, because that was like the final touch to this application. So now our client's fully satisfied and happy with what we've developed, and they're just excited to keep it going. And they actually took, about 2 weeks ago, a previous version to the UNAVCO science workshop and presented it to various research groups and organizations, including the USGS and NASA, which are two of their funders, along with the NSF. And they were all really excited. They want it. They want to use this. Where can they get it? And our client is going to make this some sort of free license. They're not sure how all that technical and legal stuff works, but find a way that they'll be able to give it to other universities that have similar research programs in GPS networks, that including the University of Washington and UC Berkeley. Those are two of their first schools they're going to hand it out to, that will be able to contribute further and use the software. And so it's kind of, I guess, a little bit of bragging there, but we're really excited about it, that we were able to develop something that will have an impact in the future and on the earth and human life in general. And we've learned a lot in this whole process as a team and worked well together. And we thank you all for listening, and now we'll answer any questions you guys may have.
Curious about, this scaling problem and how you approached modifying the code for the graphing.
Kyle, do you want to explain? I want to too, but
so they have a method of, they have these scale policies, and by default it's a kind of scaling, and we also have those axis labels on the bottom that label from negative. At 5 minutes, it's -5 to 0, or -24 to 0 for 24 hours. So we're also using that as a labeling system, and with that labeling and a few other things, we weren't able to do it originally, but actually once Sergio got that aggregator in, and he also created a few other things for the real-time, for our actual real-time and working with our database, we were able to control when points were added and things like that. So originally we weren't able to do it, so we were avoiding it. And once we realized that we really had control over when points were being added and what we were doing with all of that, we could actually update using one of their already existing scaling policies. And so we just gained control as we started working with it more.
yeah.
And
Well, the way I look at it is, so you have this graph with all this data, and then you have your window, which is what you can see, and we've made it so it just updates and shifts the window over to view the data and lines it up with the correct time. So instead of having the data just coming in and compressing, it's just showing you what you want to look at.
So what I'm hearing you say, you ended up not having to change the code that came along with
we did have to write
2D.
We did have to write some of our own things like the data collection, and also, with that data collector and the aggregator, we essentially had control over when we had points. So once we had that, no, we didn't actually have to change much. We just had to set some properties constantly.
Yeah, we had to extend the chart still, but that was more for visual stuff. Not the axis scale in the end was all there for us. Dr.
So you did or you did not make extensive changes to JChart?
We more extended classes that were there and made them fit better with what we were wanting to do.
Okay. Was there any, like, did you return any of that work back to the project? Did you, like, attempt to, or do you have plans to?
Oh, to the creator.
Worth doing?
I don't know if it's more, it was stuff that, like the button features being built in. The labeling maybe could help them because the way they're automated labels, they were in the weirdest places. And you couldn't see anything, they would disappear. So that could be something, a bug. I know they're continually, if you read things, the guy that developed it to start with, constantly updating, this is going to be in this release. So there is ways for us to send in stuff if we do want to.
Also, with the axis title on the y-axis, there was a positioning issue where they were returned. Okay, so it's rotated on the left, so they had to get width on this labeling, and it was returning the wrong thing. So we actually had to just completely redo that class and redo all the private variables and all that, and return the correct result, because it was returning the width when it was sideways and not taking into account its rotation. And so there was a huge gap there, depending on how long the string was for that title. And that, so we did fix a few bugs.
Yeah, that could probably be, because you don't notice if you have one letter, just your Y label, because the Y either way is about the same. But when you put a whole word in there, it's like the Y's are this gap. So.
Any other question?
How much does this depend on the next versions of JGraph? So if they modify something there, will this be something?
I think if they wanted to update it, they could if a new version had something that was more important. But I think since we have this version, as long as they keep it along with it, it'll stay that library.
Yeah,
the library will stick with it.
Yeah. We're just extending things. So just like Java, if they don't change any major features, it's if they just appreciate their old material and don't drastically change what we're using, they can update it and use some new features even.
Yeah, but the library, we package it along with it, so it's not... It would just be if they felt like, if something new came out and was better, it probably wouldn't be too difficult to implement if they fix those features that we fixed ourselves. All right, thank you.
All right, thank you.